Modern surveying, large-scale construction, and mechanized agriculture rely on geospatial precision to function. A deviation of a few inches can misalign a property boundary or ruin a field grade. To maintain this level of accuracy, these operations depend on a constant, invisible tether to GPS satellite networks, but that connection is easily lost. Moving under a dense forestry canopy or descending into a deep construction trench can cause the GPS signal to drop instantly. This creates a significant operational gap. When the connection to the grid is severed, the digital models used to guide high-stakes industry work lose their point of reference. Soil Sidekick Pro originated in 2025 as a tool for capturing remote soil data, where technicians frequently encountered these GPS-denied environments. In sectors like environmental compliance and crop insurance, location data captured with a drifting or degraded signal is worse than having no data at all. Minor geospatial errors can invalidate a legal land use assessment or corrupt a risk model. If the coordinates are not verifiable, the entire dataset is commercially unusable. Faced with this challenge, engineers had to develop a completely new method for verifying location accuracy without any external reference signal. The 2026 patent update addressed this through an offline first positioning system that functions independently of satellite networks. When GPS drops, the system pulls data from internal sensors. Sensor fusion uses the IMU and magnetometer to track orientation. Adaptive stride estimation reads the cadence of the user's steps. Step-based dead reckoning then projects a continuous path outward from the last known GPS coordinate. This transforms the movement of the human body into a data point, allowing for navigation in environments where external signals cannot reach. But an internal map requires a way to prove its own accuracy without an external referee. The solution is uncertainty gating. As a user moves further from the last GPS point, the system calculates a growing margin of error. If this mathematical radius exceeds a threshold, the gate closes, preventing data with high uncertainty from syncing with the master database. This creates a verifiable record of movement, ensuring that only data that meets strict mathematical standards of integrity is preserved. By providing a mathematical guarantee of accuracy in offline environments, the 2026 patent expansion moved the technology beyond its original agricultural scope. Maintaining data integrity without a signal makes the system applicable to new markets. In construction, it maps trenches and boundaries where GPS is blocked. For insurance, adjusters verify claims in disaster zones where communications are completely destroyed. Because this system provides a standardized, verifiable module for positioning, it can be licensed as a core component for third-party handhelds and surveying hardware. Today, the modern tech market is built entirely on the assumption of a continuous connection to the cloud. However, the most critical data is often found in places where that connection fails. The value of a geospatial system is ultimately defined by what it can prove when it is entirely offline. In a global economy reliant on precision, the technology that remains certain when the signal drops holds the strategic advantage.